Suppose we want to solve these exponential equations. Now notice in these equations that our variable is in the exponent, which is what makes them exponential. Now what we want is to have the same base on both sides, and the base is this part right here that is not the exponent. Alright, so our first base is a 3. Over here our base is a 9. If we could get these two to be the same, then we know the exponents would also have to be the same in order for the equation to be equal. So I'm going to leave this one on the left alone, but I can rewrite 9 as 3 to the second power, because of course 3 squared is 9. And now these two bases are exactly the same, which means that these two exponents, x plus 5 and 2, have to be the same. So let's just solve that equation. Let's subtract our 5, and we get that x is a negative 3. Alright, now we're going to do exactly the same thing for the second equation, but I can't really write 8 with a base of 4. 4 to the second power is 16, not 8. But what we can do is rewrite both of these with a similar base. 4 is really 2 to the second power. And then the 4 really had the exponent of x minus 3 out here, so we have to keep that. And then 8 is really 2 to the third power. Think about it. 2 times 2 is 4, times 2 again is 8. And then of course the 8 had this exponent out here. Now, we're almost ready to set the exponents equal to one another, but we need to simplify them first. We have this 2 raised to the x minus 3 power. All we need to do is multiply it. 2 times x minus 3 is 2x minus 6. And over here on the right, we have this 3 raised to the x plus 5 power, so it's 3 times the x plus 5, 3x plus 15. And now we have a base of 2 on the left, a base of 2 on the right. The two exponents have to be equal to one another. So let's solve this equation. First, I'll move the 2x. I'll still have a negative 6 on the left, and 3x minus 2x is just x. And then I'll move my 15, and I get x is negative 21.